When we are dealing with bone deformation corrective shapes, we can of course use the pose space deform toolset. But sometimes this is a bit more than we need, or we want to do something different the way corrective shapes are handled. When this happens, it is probably best to create our own workflow. First, let's look at our geometry. We have a character geometry, a biharmonic capture, some capture rates painted, and this is our ray shape. In the end, we have a bone deform applied to it, which applies bone deformation to our geometry. For this example, we will create a corrective shape for the elbow. When we rotate the elbow, we see that the formation here requires a corrective shape. But since we need a corrective shape that will be used before the bone deform, and our corrective shape will be created after the bone deform, our workflow will be a bit different than the one we used to create a blanch corrective shape. This is because we must apply an inverse skinning method on our corrective shape in order to get the shape without the bone deform. For this, we will create another bone deform, which will be used just to hold the pose at which we will create the edit. So let's rename this new bone deform pose bone deform, and we want to keep capture attributes because the shape difference node that we will use later needs them in order to make the inverse shape. After that, we will create the edit sub and make corrections. So let's fix a loss of volume in this area. Maybe a little sharper edge on the outer side. There, something like this will do for this tutorial. So now we can create here a null node, and let's call this corrected shape. And now we can create our shape difference node. In the first input, we will connect the ray shape. And the second input are corrected shape. And the difference method in this case will be the predeform. This is because we want to create a shape that we can use before the bone deform. What we need now is a transforms path, and for that we will need to create a chop network. And in our chop network, we will extract the bone transforms by using the extract bone transforms node. And under geometry path parameter, we need to set it to a rest null under the geometry. So here we just create another null called out. So now we can go back to our shape difference node and set it to chop networks out null. And this way the shape difference node has the bound transformations that it needs to create the inverse skinning deformation. And one thing we must set is the skinning method on the shape difference node. It must be the same as it is on bound deforms, which in this case is linear. So we must make sure that the skinning method here is also linear. So once we have created the point difference shape, we can create a point triangle which will blend in the corrective shape. And as in part 1, the shape difference gives us the absolute point difference positions. So we can just add those values to our original rest shape. Again, we will use the point triangle for that. In the first input, we will put the rest shape, and in the second one, the shape difference. Let's just rename it to some positions. And now we can just add values. With the blend parameter, we apply how much of this corrective shape we add to our rest shape. And the value of this blend parameter will be the elbow rotation divided by the value of rotation at the corrective pose. So we go to our elbow bone and take the current value, which is the value for the corrective pose, and we paste value and also paste relative reference. So this is our expression. We also want to work this only in the positive direction. So here's the max. So if we look at our blend parameter, when it goes to 0, we blend nothing, and then once we go the positive direction, we blend in the corrective shape. So now let's connect this to our bound deform. We see that our corrected shape is applied correctly to the bound deform. The only problem we now have is that the corrective shape is not correct if we rotate the elbow back, because the pose bound deform here is updating the predeformed shape as well. So what we must do now is store the bound deform pose. And for that we have to go back to the chop network and create a stash node which will stash and store the current bone rotations. First, let's go back to the pose at which we made the pointed its corrections. So we're gonna just copy this value back to the bone rotation here. Then we'll go to our chop network, create stash sub, and stash the input, and go to the pose bound deform node and set the transform path to chop networks. Chop networks out null. Okay. So now if we rotate this elbow, we're going to get the correct deformation. And this is because the pose deform node is not getting the updated bone transformations, because it's getting transformations from the stashed chop network. So now just how to connect this everything into a rig if you have multiple blend shapes or corrective shapes. In this case, we should create blend shapes and connect the first input into the rest, and then all the rest into these corrective shapes. So for instance, this one would be corrective elbow, and we would ignore this blend parameter here. We're gonna just copy this expression and just delete this blend parameter, go into our blend shapes, and just paste this expression here. So more and more of these correctives, we will just plug them into the blend shape and then also add the expression as we did for the elbow. So this is it for the second part of corrective shapes in Houdini. I hope it will help you with your own character rigs, and see you next time. Bye bye.